Hello, everyone. Welcome to the TMC Pool Fund Study Emerging TMS Topics webinar series. Today's webinar topic is using VSL during adverse weather events. My name is Saidan of Morshid, and I'll help facilitate today's webinar. As a quick reminder, at National Operations Center of Excellence, we offer a variety of resources to support the transportation systems management and operations community. You can go to NOCO's website to browse through links for TISMO resources and news. Previous webinar recordings and case studies can be accessed from there. Now I'll cover a few logistics for today's webinar. We're recording this webinar, and the recording will be available on NOCO's website. All the attendees are encouraged to stay engaged by using the Q&A feature for questions and chat feature for comments. These are both located at the bottom of your screen. We have a question and answer session at the end of the presentation. So if you have any questions, we encourage you to enter them in the Q&A area as they come to your mind at any time. Also, please feel free to enter your name and agency in the chat to say hello to your peers. So I will launch the starting poll questions now. So please participate. You can see the questions in your screen. The first question is, what organization are you affiliated with? So please go ahead and participate in the poll. And once you answer the first question, you can scroll down to access the second one. The question is, what is your role with your traffic management systems? I can already see people participating in the poll questions. So I'll give it a minute. We can see mostly folks from public agency state are here, about 43%, and private agency 27%. 10% from academia and 7% student. That's fantastic. And we have mostly the people from traffic control management, traffic incident management, researcher, and contractor as well. That's awesome. So I'll give it a few more seconds. I can see almost 87% of the attendees have participated in the poll. So if you haven't participated in the poll, please go ahead and put in your answers there. In the meantime, if you have already participated in the poll, please go ahead and say hello to your peers by mentioning your name and your organization in the chat box. I'll end the poll now and share the results. I can see a good blend of answers. So thank you for participating in the poll. Let's move on to the next one. So today's agenda, as you can see, we have 3 presentations. First of all, there will be an overview provided by Tomas Lindheimer, and followed by 3 presentations from Les Jacobson, Chris Siavrakas, Cody Oppermann, and Ryan McNary. And last but not the least, Vince Garcia from Wyoming DOT. The topics are challenges with managing traffic during adverse weather, agency practices and lesson learned, and agency practice and lesson learned from 2 different DOTs, Utah and Pennsylvania, and followed by the Wyoming DOT. At this point, let me just quickly. Yeah, I'm gonna hand it over to Thomas. Thomas is a transportation engineer at Texas DOT and will be providing an overview of the TMC PFS, who is co-sponsoring today's webinar. So the floor is all yours, Thomas.
Thank you, Anaf. Welcome everybody to this webinar. Next slide. Just want to give a quick disclaimer to remind everyone that this presentation is co-presented by the FHWA and public agencies. Views and opinions expressed are the presenters and do not reflect those of the FHWA or DOT. Next slide. Today's learning objectives are to learn about the TMC Pool Fund study and the work that it is doing to identify and address key issues and challenges faced by the TMCs, identify operational practices for using VSL during adverse weather events, and hear about lessons learned for effective implementation of VSL. Next slide. The TMC Pool Fund study is a group of 25 agencies and organizations who voluntarily pool funds each year to address key challenges and issues they're facing in support of improving performance, capabilities, and how they manage and operate their TMSs. If you want to learn more, go to the TMC PFS website listed on the slide. Next slide. The TMC Pool Fund Study Evaluator enables agencies to interact with other TMC managers experiencing similar technical issues and provides an opportunity to collectively identify issues, provide insights into projects, and help shape resources that TMC Pool Fund Study is developing. Next slide. I very briefly want to reference that there are 9 current funded projects coming out of the Pool Fund Study, and that there are 3 upcoming projects where additional information is available. Next slide. And also, the other TMC Pool Fund Study supported projects include 3 NCHRP projects listed here: NCHRP Project 3, 148, 151, and 152. Next slide. The TMS portal at the website here listed on the website on the slide serves as the one-stop shop for agencies to access and share information on TMS related issues. I encourage everyone to use this website as a first place to look for information and share lessons learned or resources that you have. Next slide. So again, NOCO and FHWA are co-sponsoring webinars on each of the TMC Pool Fund studies selected. Today's webinar is about using variable speed limits during adverse weather events, but we are sponsoring topics and we have regular webinars every other month on 12 emerging TMS topics through 2026. Visit NOCO's TMS emerging topic website for more information. Next slide. And with that, we're going to start with our first presenter. Is Les Jacobson. Les Jacobson is principal at L&J Transportation Consulting, and will be providing an overview about why this is such an emerging topic. Les, time is yours.
Thank you, Tomas. Next slide, please. So what we're going to do today is first, I'm going to tee the topic up with some of the things that we found as we looked into this emerging topic. We talked to different agencies, we did some web searches, we brought things together, we presented that through a white paper to the pooled fund study, and then from there we developed a fact sheet and also this presentation. So in this presentation, I will be talking about the things that we learned from that research, and then there will be people who will talk about what they've done in their agencies that deal with the topic of how to deal with adverse weather through things like the variable speed limits, specifically the variable speed limits. So some of the things that we found that agencies face in terms of challenges include that there's very rapidly changing weather conditions that they need to respond to and react to. A lot of times drivers travel too fast for those conditions, and also those increased speeds and actually the speed differential from some travelers traveling too slowly to those traveling too fast increases the risk of crashes. So there's some operational strategies that these agencies will share that will deal with how to address those changing weather and roadway conditions. VSL is a strategy to consider during adverse weather. I think it's been proven pretty effective in a lot of areas, especially in mountain passes, but not exclusively to mountain passes. And it's also important to think about how VSL can be implemented and then operated in these changing conditions. And specifically, that usually includes integrating that into your traffic management system. Next slide, please. So variable speed limits, or sometimes variable or dynamic speed advisories, but mostly for weather, it's variable speed limits, help to manage traffic, to slow traffic down, to improve safety and reliability when there's adverse weather. Agencies will alert drivers of what the conditions are, and then encourage them to slow down by posting a lower speed limit, and then also displaying the conditions that they're about to experience on changeable message signs. Agencies will also share information through a lot of different notifications, through traveler information websites, on social media, a variety of ways that they can share that information to drivers and to the media and others who are interested. And they also will inform some of the other public agencies like state police or state patrol, maintenance teams, emergency responders, all of the people who may need to deal with traffic in adverse weather conditions. Next slide, please. Some of the benefits that we've seen from variable speed limit in areas with adverse weather. First, to improve safety and reduce number of crashes. I think that's the number one benefit, and that's why we have it listed here. It's primarily a safety issue. It also helps to reduce crash-related road closures, so it helps with maintenance overall and reducing the load on maintenance workers and maintenance funds. Also, it increases driver awareness on why travel speeds are being adjusted and the importance of slowing down in these conditions. And then also, we've seen some of these positive before and after results. For example, Ohio DOT showed that they reduced crashes during snow events by 35%. Ryan will talk more about that later. Also, decreased injuries and fatalities from 20 to 9 crashes per year. So that's a pretty substantial reduction in fatalities. Wisconsin DOT also found that they reduced average vehicle speed by 13%. And Utah DOT found that they improved speed limit compliance and significantly reduced crashes as well. Next slide. So what people want to do reflect a lot of those benefits. Generally, the desired outcomes of using VSLs during adverse weather is to improve safety, to improve travel time reliability, to reduce vehicle speeds and speed variations, and to improve driver awareness of the adjusted speed limit and also compliance with it. A lot of studies have shown that if people understand why they've been asked to slow down, they're more likely to slow down. So I think that's one of the most important things. Also, want to be able to manage that variable speed limit based on changing circumstances. So it needs to be somewhat dynamic, so those speeds can be changed based on the changing roadway and weather conditions. Also, then another desired outcome is to share information and coordinate with emergency responders and service providers. Next slide, please. So some of the things that agencies consider when they're thinking about using variable speed limits during adverse weather conditions is first around enforcement. And should there be regulatory or advisory speeds displayed? I think very often with adverse weather, the regulatory might be more important. That's a personal view of mine. I think it has a bigger impact. Also need to think about effective sign locations. Where should the signs be? And that will depend on what the kind of normal weather conditions are and how far in advance speeds can be reduced and reduced effectively. Also, what other operational strategies should be incorporated in this overall traffic management during adverse weather? And it's important to realize that the benefits can vary quite a bit from site to site, and there's a lot of uncontrolled factors, and some of those are, you know, the mix of the motorists. How aware are they of the events that are going to result in variable speed limits? Certainly, people who are new to that area, aren't experienced driving over that stretch of roadway at that time, they may be less aware, and that can affect how beneficial it will be. That also leads to speed limit compliance rate. People who understand it more are more likely to reduce speeds. Also, this all leads to driver behavior too. The more people who are unaware of the results are probably, or of the events, are probably less likely to have had that behavior people are looking for. However, keep in mind that there's a broad array of drivers anyway, and some of them are going to be less likely to comply just by their nature. And finally, road geometry will also have an impact on benefits. Next slide, please. So some of the challenges then with implementing variable speed limits, and because they vary from site to site, that's kind of a challenge when you're trying to say what the kind of benefits are. And some places they may be lower, some places higher. These variation in benefits we covered on the last slide, but just be aware that there's some challenges with that. As one location opens after another, there may be some that have better benefits than the other. And sometimes people can question why, if there's a drop from one location to another, why did you choose that? Those sorts of things. And then typically the compliance is lower if the speed limits aren't enforceable. Finally, another challenge is that youth across the state or region may benefit from things like knowing when and how to change speeds. So that means there's a challenge in getting that information out to the driving public, and then conveying the relevant information so that they understand why variable speed limits are used and how. And finally, sometimes there's challenges with applying policies and procedures consistently across a region or across a state. Next slide, please. So some of the support for using and managing VSLs include the traffic management systems need the capabilities and the resources to support actively managing those variable speed limits. That's one of the most important things about dynamically managing variable speeds is to have a central place that it can be controlled from, a traffic management system that can do that. And those traffic management systems need to be able to collect and process data. They need to disseminate information to travelers, emergency responders, other people who need to know about the conditions. And then the TMSs need to continue to monitor how weather is affecting traffic. Next slide, please. So some of the issues to consider when thinking about incorporating variable speed limits into your traffic management system include thinking through the operational requirements of the traffic management system. And really those requirements are pretty similar to a lot of other traffic management system strategies. There's also probably some need to establish formal operating procedures for when the variable speed limits are operational and how to support those and how to operate the system. The traffic management systems may also need to automate the operation of VSL, depending on what the conditions are and how quickly they change. But at the same time, an operator needs to be in the loop so that they can monitor what's happening with the system, make sure that it's reacting correctly, and make changes if it's needed based on experience and the different conditions that are going on. And then the TMS needs to be able to communicate with responders and other agencies. Next slide, please. So there's also I think the benefit of having the variable speed limits with changeable message signs. We've mentioned that throughout here. That's a way that we can get information to the driving public. They're important for traffic control purposes. The messages need to be easy to understand, just like any other variable, any other changeable message sign. And there's a bunch of documents that can help to show how to effectively use CMSs. Next slide, please. So here's some considerations. I'm just going to point out a few. It's really important to know what your staffing needs are going to be, and that includes number of staff and also how to train them. It's really important to think about, is this going to be a regional or a statewide implementation? Finally, to look at reviewing the processes and procedures that are needed as well, and to evaluate the availability of the devices to provide travel condition information. Next slide, please. So I'm just going to show a few slides on some of the things that occur, and typically a scenario for changing speeds might be that there's some information about expected snowfall. The operator decides to change the speed limit, or the system sees that there's some changes. There are other things that may occur. Visibility declines, grip factor might decline, and then based on those changing conditions, the operator looks at adjusting the speed limit. Next slide, please. Ryan's going to talk more about Ohio DOT, but they looked at staffing and training needs, and he'll be talking about that. Oregon DOT integrated their speed data and closed circuit TV into their TMS to help with the variable speed limits and with the changeable message signs. And then a lot of the DOTs have deployed VSLs along routes with history of crashes, and Ryan will talk a little bit more about Pennsylvania's experience. Next slide, please. So some of the lessons learned include it's important to integrate VSL into TMS. The implementation of VSL does not always require new positions or additional training of staff. It kind of depends what staff there is and what their experience has been. But it's important to note that the requirements for the operators are similar to other TMS operational strategies. And again, the use of variable speed limits are most effective in conjunction with changeable message signs. Next slide, please. So some of the future direction includes collecting data, being able to show those benefits, and then also I think it's important to look at how one corridor or one segment of VSL can lead to increased use in other corridors as well. Next slide, please. Thank you very much, and I'll pass it back to Tomas.
All right. Thank you, Les, for that presentation. I really appreciate it. Good job. Next up is going to be Chris Siavrakas and Cody Oppermann. Chris Siavrakas is a traffic operations engineer at Utah DOT, and Cody Oppermann is a weather operations program specialist at Utah DOT, and they will be providing an overview of UDOT's use of VSLs.
All right, enough. Thank you so much. I appreciate having the opportunity to be here with you today to cover this topic. It's exciting. We spent a long time working on this, and we've learned some good things along the way, and that we're excited to share with you today. So, all right, next slide. And let's go next there. Okay, is our intro slide. All right. I just want to orient you to that we have two different variable speed limit zones within Utah, several miles long. So they're both regulatory. This one is just east of the Salt Lake City metro area in the mountain terrain that goes up towards Park City. It's about 12 miles long, and we have another one that's next slide. It's in kind of our south central rural Utah area, interstate, where the speed limit's normally 80 miles per hour in this area. But we have a high mountain pass that comes up out of the desert floor up into a little bit of a range that sees a lot of weather activity that's different than the open valley area. So this was a needed area for a corridor there. So this is the two that we've mostly have our discussion centered around today. So next slide. Going back to the Interstate 80 corridor, this one, we had a number of instruments, devices already set up in the corridor. We already had ATMS and cameras, sensors, all that through the corridor. So it was very easy to bring in our VSL into that corridor. But we've also had to make some enhancements to how many devices we had there, since the placement of those devices weren't set there for the purposes of having a variable speed limit system. We brought the variable speed limit system years later, so we had to fill in some gaps and add some weather information and some detector information for supplemental information that we needed to do the calculations required for the speed adjustments. So as you can see here, we have quite a number of devices there. One significant part of this is the bottom bullet there, the elevation range change. The Salt Lake Valley floors in the 4,000s range. Up on the benches, it starts to creep up towards 5,000. As you enter the VSL corridor, you gain a little over 2,000 feet in about 10 miles or so. And then it peaks down on the other side for the rest of the corridor coming out of that canyon. So next slide. All right, a little bit more on the zones here. So we originally had this as where the region traffic engineering staff would change the speed limit based on their observations of looking at camera images, looking at speed data, and they would make a determination. So the zones were broken up just in a couple areas. But then once we went to automation, we brought the number of zones, increased them, basically bringing them much smaller segments where we can change the speed limits. So basically it's every speed limit sign can be different from the one downstream of it. Now we have some parameters to have it smooth so we don't have huge breaks in that change, but we went through a pretty significant change from our first variation of the speed limit system to bringing in more automation components to that. And what happens there is that we're all the traffic monitoring stations there are where we're picking up the speeds from travelers on the roadway that are already there, and they're helping us determine what the speed should be. We kind of call that voting for the speed. So that helps the algorithm figure out what we should be posting on the upstream sign of that zone. All right, next slide. All right, this is the little snapshot down in our south central area as well. Not as many devices, not as long in length, but again, another elevation rise. We're a little bit higher in elevation on that plateau, but then it does rise up sharply 1,000 feet. And sometimes that's a significant difference in the weather. You may have a cloud ceiling just above you that's maybe just lightly raining, but you go up a little bit in elevation around that range, you may now turn into snow or ice in those situations. So this is why that was applied at this location. So next slide. A little bit of snapshots of what there's a couple photos piled on top of each other. They're supposed to fly in, but that's okay. This is a PDF version of the presentation. But if you've ever been in that kind of situation, daytime or nighttime, it's difficult. It's white knuckle moments where you're trying to just navigate this corridor. You're trying to get somewhere. You know, if you had a choice of not to be there, maybe that's your better choice. But sometimes people still have to get through the corridor. Helping them understand what those travelers downstream are doing with their speed is helping us make the calculations on the speed as they're entering the corridor, so they know how to target their speed if they're unsure of the situation they're dealing with. It just helps reinforce where they ought to be trying to find their target speed for what's lying ahead. Next slide. Real quick, I'm not gonna go through this point by point, but about 10 years we've been working on this technology. Went through a couple rounds. I mentioned our automation development, and then the exciting part about this, I want to give time to Cody after I'm done here to talk about the weather aspects of how we use weather information to change the speed limit. But we've enjoyed having this experience and time to develop and improve steadily through the life cycle to date. And then we just recently brought online the I-15 Baker Canyon. Now, one thing just to note there, that took a longer time to commission and integrate. That was in a corridor that had nothing. Like, it's far away from any power sources. Communication was not readily available. In contrast to that, to the Interstate 80 corridor, where we already had a significant ATMS instrumentation infrastructure, it was easy to bring that in within a year's time versus taking a little bit longer to develop all the components out in a very desolate area of the state. So and we just had our go live for the Baker Canyon this past winter. So we've only had about half a winter, and it was kind of a lighter winter than usual to round out our experience with that. So we just kicked off a consultant to look at some machine learning. One of the challenges with that is that in those times when there's not a lot of traffic on the roadway or in the wee hours of the night, it's kind of hard to get enough of a sampling of where to place the speed on that in an algorithm. So we are exploring that. We'd love to have a future time to talk about that, but we're just barely starting that discussion now. Next slide. So how does UDOT get to make these changes? So when people consider speed limits, and Les may have alluded to this in a number of different ways already, is each state is going to have their own statutes or code or laws or whatever to help start that conversation about where do we get to do that. In Utah, we enjoy a lot of flexibility in how we do that. Basically, go ahead and hit the next slide. The code gives us the UDOT the authority to make this speed changes based on weather conditions, a number of other things, but weather conditions and other safety factors. So next slide. And so yeah, instead of reading the small print there, that I just showed a sample of that. But here's more of the details where we can do that. Where we have to have some kind of a study that helps determine that. So we can't do regular speed studies that you do like on arterial corridors with traffic counts and evaluations and take days and weeks to figure out what you're going to change the static speed sign. This has to happen within minutes. So the process we go through is more of an engineering design process in real time. So next slide. So in reference to how we can do that in our state law, it gives us that authority to do that. Next slide. So this is out of the manual and uniform traffic control devices. There's 2 sections in there to discuss engineering study, and the procedures that we're talking about here is the application of procedures and criteria established by the engineer. So we have an engineering team that reviews this and decides how this process is going to work. So that's our interpretation of how we're applying that authority to make that determination in real time for traffic speed limits. Okay, next slide. So challenges I've mentioned before. So in Utah, we subscribe to the prima facie speed law, or the basic speed laws. It's also referred to, which is basically whatever is reasonable and prudent for the prevailing conditions. So we have to basically take samples from what the population is deciding what is safe for them to navigate that corridor, and we average that and come up with some kind of a number that's going to say that should be the speed that other people should follow. So that's why we call it voting for the speed. They're basically casting their vote when we collect that data sample from a sensor. That's their choice of what they think should be the speed. So, but the sampling size is impossible to have a statistically significant sample size because it's going to change every 3 to 5 minutes. We may only get a dozen, maybe 100 on a busy day through a corridor during a few minutes interval. So we have to have we have to be comfortable with how to do that, make that change within a small sample size. Okay, next slide. And we also anticipated that we don't want to get stuck in the records request process. We basically publish on our website all of the commands for each of the signs out there that give the speed to that sign. Now we can't prove what was posted on the sign. We can only demonstrate what was given from our TMS software to give that instruction to the sign. So Highway Patrol or citizens or anybody that want to do any research can go to this website link. They can download, they can pick the signs they want. They can export this into a file, a CVS file or a PDF. And we don't get involved in the records request process. We just make it available to anybody. So next slide. All right, so next I want to turn it over to Cody Oppermann. He's our weather program specialist, and he's going to talk more about the recent version that we've come through with changing the speed based on weather parts only. We had the I-15 section of that. We wanted to be able to lower the speed based on weather conditions prior to travelers responding to that. So I'll let Cody discuss the rest of that.
Yeah, so as Chris mentioned, wanted to see how we can kind of integrate RWIS into this. I think most states, you can go ahead to the next slide, utilize RWIS for their VSL system. So we've talked about initially when we did manual changes of the VSL speeds, the operators or engineer who was operating it looked at weather data, but most of that manual transition was delayed. There was pretty good latency. And then the automation was solely based off speeds, as Chris talked about. But we wanted to see what can we do with the RWIS data to make to see if we can improve things. So we decided that when weather is coming in, we wanted to get speeds lowered before they have to start to react to the changing weather conditions. So what we decided here is we see some variables indicating weather's coming in. We'll lower that speed limit ceiling, as we'll call it, down 5 miles per hour in Parleys, which we haven't initiated yet, but hopefully this winter we'll have that going. And then 10 miles per hour on the I-15 section, since it's a higher speed limit there. And then after that speed limit ceiling, then you get the vehicles voting, which drops the speed further. But then, so basically the whole idea with the RWIS here is just to catch people initially and get them to slow down. Next slide. And so there's 5 different kind of things we look at. And I think I was looking at Wyoming slides, and they kind of do a similar thing. And I think other states do for certain types of weather scenarios, where we look at, and I'm going to go quickly through this, but we look at standing water based off, you can see a sample RWIS tower here with the different instrumentation, what's being used. But if there's water on the road of a specific value, low visibility, high winds, if the road grip or coefficient of friction is deteriorating, and then a complicated algorithm for snowfall rate. But if we start to see any of those, observations showing deteriorating conditions, that will trigger this lowering of speed, the speed limit ceiling, if you will. We originally had 10-minute observations. To reduce latency, we went down to 5-minute observations, and because we want to see a deterioration in the conditions, as well as kind of if there's any one-off bad observations, we kind of weed that out. Most of these conditions we take 2 subsequent observations to show a deterioration or that conditions are bad enough. And I think I'll gloss over the next 4 slides here if you want to skip through. You can kind of look at these flow charts for what initiates a weather event. Wind gust, we trust that data enough. If there is a strong wind gust for one observation, that will trigger the VSL. Both of these corridors aren't traditionally a high wind or crosswind problem, but we have that in there just in case. So next slide. Next slide. And then at the end of a weather event, as conditions start to improve, we notice people their speed starts to kind of dramatically increase. But we didn't want to say, hey, don't go full speed just yet. There still could be problems in the corridor, weather still being an impact. So all these variables, as you've seen here, are like we can tweak them based off the zone that we're in. Also go back and say we at least have a full RWIS station in each zone, or at least a road sensor to determine some of these variables. And then that'll impact the zone that it's attributed to, and then can filter if it's just the one zone that's being impacted, then you'll go back to normal speeds on the zones adjacent, but that'll at least trigger that the entire corridor could have weather problems. But anyway, so at the end of a weather event, we need to make sure all the variables come back to a safe condition for speeds to go back up to the normal speed limit. Next slide. I was going to show a quick example from last winter. We noticed an issue with our algorithm that we need to go back and fix in the I-15 Baker Canyon section. This graph real quick shows that boating speed. That's kind of a complicated thing, I think, how we come up with that. But and then the orange line is kind of what that ceiling speed should have been, and we should have triggered an event sooner and ended sooner. But anyway, next slide. So a little bit, I took an example from a long time ago of how this should have operated. You can see here, this was back in 2020, but a storm that happened in November. You can see the weather variables there. I've highlighted some of those variables where we're starting to see an uptick in the snowfall, and coefficient of friction started a light decline. And then this chart on the upper right shows the aggregate speed across the lanes there on this eastbound zone. Next slide. I had to interpolate the RWIS data since we were taking 10-minute observations, but let's say that if it was 5-minute observations here, you see the snowfall rate ticked up a little bit more, road grip stayed the same, but we haven't triggered any of the thresholds from our algorithm yet, but speeds are still elevated. Next slide. Again, conditions are deteriorating, but not quite yet. And then next slide. We've hit our thresholds for a weather event to begin. The aggregate speed there is 63. So we've, at this point, would have theoretically lowered the speed to 60 and got people aware. And you can see in the camera image how the storm is picked up. And we also, I didn't mention this, but we also are looking at these 2 subsequent observations in case you had like a passing flurry over a course of 5 minutes that we didn't want to pick up on. in case the weather data returned back to a better state. So it had to show deteriorating condition, and this is how this would have worked theoretically. Next slide. There's some various groups doing research here, and then Chris mentioned the machine learning project that we're doing, so I won't spend time here. Next slide, and then there's our contact information if you have any questions. That's all.
All right. Thank you, Chris and Cody, for your presentation. That was great. Next up is Ryan McNary. Ryan McNary is the Chief Operations and TISMO Performance at Pennsylvania DOT, and we'll be talking about Pennsylvania's DOT's use of VSLs.
Well, first off, thank you, Utah. That was awesome. I learned a lot. I was taking like notes. I was like writing everything down there. But anyways, thank you for having me. Ours is not as mature, but I think it could show you from a different stage how this could be deployed on a more temporary basis and in areas that are more rural and that may not have comms. So you can go to the next slide. There you go. So right now, we have 3 areas that have large areas that have portable VSLs. So the ones that are circled red were there since 2021 or 2022 winter seasons. And then green was last year's winter season. And then the green out towards Ohio is coming this winter. We do have a permanent corridor outside Philadelphia that uses VSLs, but for the sake of this conversation, I'm going to be focusing on all the temporary deployments. You can go to the next one. So this is what the devices look like if you're unfamiliar. We have them deployed out there a lot of times behind guide rail to protect them. And then we work with our local district engineering districts and maintenance crews to build pads for them. So they work off solar, they have battery backup. That has been some maintenance concerns to the devices. So some of these are around 3 years old. We're working on that. We've had to replace some batteries. And then another thing that we're working on right now is the modem optimizations. So these come standard with either contractor modem, but from a DOT perspective, you're going to have to consider your comms and bringing them into your actual ATMS and your control equipment. So we are in the process of bringing them into our corridors module, is what we call it in Pennsylvania. It's essentially an active traffic management module that has our WIS station, speed data, so we can automate these things. So we're getting to the point where this winter we're going to be piloting automation around weather, much like what Utah just talked about. So these are the devices we have out there. So we're swapping out around 90 modems currently, and moving forward, we'll be able to use the algorithms we build into the existing corridors module. So you can keep going. So how did we pick these locations? We ran a lot of data. I think we looked at tens of thousands of RWIS station readings to understand where would be the primary locations we consider as. Now, if you're not familiar with Pennsylvania geography, we have the Appalachian Mountains. So they essentially run from a little west of Pittsburgh to the Harrisburg area, which is, if you can't really see that, but it's the I-81 corridor through to Allentown. And if you're following that to New York City, up to Maine. So it's going to follow that swath of land. Now they're not as big as the Wasatch Mountains out in Utah, but there's some significant grades. And we get a lot of crashes, and unfortunate those major pileups that we never want to make the news about. So we decided that this was going to be a solution for us. And you saw the corridors earlier, and it seems that we're going to be expanding this statewide in other policies for our core roadway network. But what's showing in front of you is of those tens of thousands of readings from the RWIS stations. The larger the circle on the left is the number of stations that saw what we would consider whiteout conditions. It was something that in our study we determined what a whiteout would be from a DOT perspective. And then on the right hand side, we correlated that with crash data. to understand where we had those bad crashes and when they lasted 3 hours or longer. So you can go to the next slide. So we took it a little further. Some of you might have seen me look at this before, but this was the start of our automation. We're trying to do what Utah is doing, get ahead of the storm. So it's a little different from a weatherman perspective. We're trying to prevent crashes here. So we're looking for that tipping point and that likelihood of a crash. So we have low visibility, high wind, freezing surfaces, freezing rain, and slippery surfaces. The freezing surfaces and the slippery surfaces is what we're trying to pilot this winter. We see a lot of times that initial changeover of the storm is when we get a lot of our crashes. A lot of people aren't expecting it. The variable conditions come in quick, and we're gonna shoot to have the VSLs and then the associated CMS boards to help protect those areas around where we have RWIS stations. So we have around 95% RWIS station coverage on our core roadway network. I've said that a couple of times now. That's around 4,000 miles of roadway in Pennsylvania. We manage around 40,000, so it's roughly 10%. So it's your interstates, your interstate local lights, and your major arterials. So you can keep going. So in Les's introduction, and I think with what Utah talked about, part of making this successful is CMS support. We've now piloted for a couple of years. How can we automate this? And we started with Q protection. We last year did high winds and whiteout conditions in our Erie district, where we get the most snow, and in the I-80 district in our northern tier. So what that does is it pulls those readings based off the visibility less than 1 mile, the rain state medium to heavy snow, and rain intensity above 0.04 inches per hour. Now, so I alluded to this earlier, that doesn't constitute a whiteout to a meteorologist. But for us and for the drivers, and you're traveling at significant speeds, it makes it very difficult to drive. And that was our threshold and our tipping point where we wanted to, in those 15-mile radius, post these messages as people were approaching these conditions. So we do that for high winds too. We have some bridges that are exposed in central Pennsylvania where we essentially soft close the bridge if they reach speeds above 50 miles per hour. It doesn't happen often, but we do that for specific bridges and corridors around the state as well. This was automating these messages was a work in progress with your TMCs, I'll be honest with you. Working out the priorities, working out how they override incident messages, working out how they override with vehicle restriction messages is not an easy process, especially when you have a lot of decentralized management. So I would say put some effort in the beginning of that. You're going to try to figure that out. And you can go to the next slide. I talk about that a little bit. So how we had to figure it out for our ATMS system is we needed a business rules engine. There's just so many variables that are going to go out there, and they change by every geographic area. One 15-mile radius might be a valley, the other might be a peak of a mountain. So what we've done is we've brought in a business rules engine into our ATMS platform that has the ability to look at slow or stop traffic. So that uses the INRIX data. And then it looks at the mile differentials of where those speeds are. And then if those speeds cross a threshold, we can essentially lower the VSLs ahead of those speed drops, and then also post Q protection messaging. And we're going to use that same methodology for weather as well. Right now, you can see at the bottom, the weather station search is at 15 miles, and then we can customize it by corridor. And the one example you see there is District 1, that's our Erie city area, and on I-90, which gets the most lake effect snow in Pennsylvania. So you can go to the next slide. So where I am today, I'm actually at our statewide TMC operations meeting in north central Pennsylvania. So I'm in Clearfield right now, talking from their TMC. So They were our first portable VSL or temporary VSL corridor, and we deployed this in the 2022 winter season. There was an unfortunate major pileup that caused a fatality in 2020, and a legislator asked us to essentially come in and work on something. So we threw a lot at this. We instituted, it was one of the first times we instituted the virtual queue protection corridor. We put VSLs out there. We partnered with all of our state police to be out there enforcing vehicle restrictions, chain restrictions, et cetera, through the mountains. So after that first year and that initial buy-in, you can see the drop. Now, it's coming out of COVID, so there might be some relationship there. But in 2021, 2022, we saw a drop from 37 crashes to 12 with one full closure, and then roughly averaging around four full closures the previous 5 years, and then no fatalities. And then in 2022 to 2023, it went back up to 27 crashes, but no full closures, and then 0 fatalities. Now they since expanded this. What we call the Allegheny Mountains is still the Appalachian Mountains, where this occurred in the 2022-2023. You can see the drop at the bottom now, where from 23 crashes to 14, from 6 full closures to 1, and then 0 to 0. So now this isn't a big data set here, but I think on the micro level, you can see there is an impact, right? We're still doing analysis on the other corridors, but we don't have a lot of the safety data yet since they're so new. But I wanted to, at least since this is our oldest, most mature corridor, show you that information. So you can go to the next slide. How does it now? We do have a lot of data on this. So how does it actually impact people's behaviors on speed? Now, this is using INRIC speed data. And what we did is we compared areas where we have VSL and areas that we don't have VSL with the same conditions and the same type of roadway. So you saw that hazardous winter conditions before and how we determined whiteout, low visibility, slippery surfaces, etc. So with no VSL, and we just posted a speed restriction, or people slowing down. People slowed down 8, -8, -3, -1. They didn't slow down at all for freezing rain. And then -1 mile per hour for freezing surface without VSL. When the TMCs, and part of our policy here in Pennsylvania is the TMCs have the authority based off of our WIS stations and our current policy to drop speeds 55 miles per hour manually still. When they see these conditions and the conditions warrant. Once they did that, you can see the difference there. So we're seeing deltas of an increase of speed drops of 6, 5, 9, 4, and 7 in those conditions. So on average, 4 to 9 mile per hour speed differential when we are using the speed in the speed drops in the VSL corridors. So that's a positive. You can go to the next slide. So when we do actual 45 mile per hour speed restrictions, which is something that has to be approved by what we call our area command, it's where I work in Harrisburg, and we have to figure out those speed drops. I don't per se figure it out, but it's a collaborative effort with a lot of different agencies. We see that in the areas with the VSL, we see an increased reduction of 4 miles per hour on the I-80 corridor, and then I-81, we saw an increase of 3 mile per hour drop in travel speeds during the last 2 winters. We have data. Go to the next slide. So this is similar to what Utah went over, and this is kind of my segue into automation and where we're at here in Pennsylvania. We have all this data. We're trying to figure out the algorithm that we want to do. We know the thresholds, and this is an example where we had restrictions in vehicle restrictions, and then we saw we turned on VSL at the below, after the tier 1. You see that below speed drop right when we started to see the surface states deteriorate, and you can see the actual driver speeds reduce to around 45 miles per hour. And then when we kept it going, the speed restrictions were reduced. So this was what we consider one of our better times, but it emphasizes the point that people listen to this when we're comparing the information that we have out there in real time. Go ahead. You can go to the next one. So automation, whoops. So automation, this is just the first time I'll talk about this a little bit, and Les alluded to a little. We're seeing that our operators, and I from my personal perspective, I think it's a hard job for our operators to become meteorologists and follow the weather stations and then get them out there. And it's a lot of responsibility for them to do that. So we're moving this way. And what I wanted to share with you all is the I-76 automated corridor that we have VSLs, our only permanent location. We've seen significant impacts in the safety data. So overall crashes in that corridor outside of Philadelphia have dropped 22% when we instituted the VSLs and the algorithm that decreases people around 1 mile ahead of these speed drops. Rear end crashes have decreased 32%. And the big thing here is when we give any type of information and make it understandable to the motorist that, hey, if you see that slow down, there's something there. The injuries and the severity of injuries significantly decrease. So you see 20% decrease, but a 62% drop in serious injuries. That is just a big win from the DOT perspective. And I know we're not talking about travel times right now, but travel times were greatly impacted as a result of this in 2021. But as things go in the transportation world, behavior changes. I think people get used to a system and they just start neglecting speeds. So we've seen the travel times go back up, and we're going to be issuing a press release with this information here in the future. But this is my pitch for automation, and we're working towards that here in the future. So thank you for having me.
All right, thank you, Ryan. I appreciate your presentation. That was great. Next up, we have Vince. Vince is a GIS ITS TMC program manager at Wyoming DOT, and we'll be talking about Wyoming DOT's use of VSLs.
Thank you. Can you all see me? I hope my camera is working.
We can see you.
Okay, great. So please, next slide. So I'm gonna, well, what happened there? There we go. I'm going to give you some information about the background that led us to using variable speed limits. I'm going to talk about the enabling legislation, tell you some of the methods that we're using, and then provide you some results. So please, next slide. I'm not seeing, okay, thank you. I don't want anybody to think that Wyoming is unique in the number of snowfall events we have. We look very similar to the rest of the country. Next slide, please. Same thing with winter severity. Certainly we have severe winters, but so does everybody else. Next slide, please. The thing that makes us a little bit unique is that we have a lot of blowing snow events. Where you see that kind of hot spot right in the kind of south central, southeast Wyoming, that's exactly where Interstate 80 crosses the state, and Interstate 80 in Wyoming is commonly comprised of about 50% truck traffic. Next slide, please. So those combination of weather events and a large number of trucks results in a lot of multi-vehicle crashes. Please, next slide. Next slide again. Not sure what happened there. What I wanted to let you know is that if there is a crash involving a passenger vehicle, especially when we come to these vehicles, a lot of truck traffic, the passenger vehicle really has no chance. So back in 2008, we had legislation go into effect that allows us to use variable speed limits for a weather or vehicle emergency. And again, it says we can use variable signs to do that. So next slide, please. We think of variable speed limits as a system of systems. We insist on having a road weather information system in a zone. We also have the sign itself, and then we also include speed sensing. And in our case, we are very rural. We don't have great communications. I know a lot of states are blessed by having a lot of fiber optic capability. Our emergency communications personnel have worked with us at length and have built basically a statewide radio-based network. So most of our systems are controlled by radio. Next slide, please. We built an algorithm that's largely based on stopping site distance, but it does include variables such as the weather conditions as well as speed conditions. Next slide, please. So what we're really trying to do is tighten up the speed distribution. As you can see, the green histogram there, if you look at the 100 on the left-hand side and the number of vehicles and intersect with the green, you'll see that in this mythical situation works out to be about 55 miles per hour. 100 vehicles are traveling, while 100 vehicles are also traveling 95 miles per hour. What we really want to do is tighten up that speed distribution. Next slide, please. The other thing we want to do is make the speed sensible for the roadway conditions. So we want to push that speed limit back and tighten it up. Next slide, please. This is real data. So in the top, you can see the ideal histogram. That was a dry and clear day. You can see that there's kind of a normal distribution of speeds. When the storm impacts, we see a large kind of spread of the distribution. So this is all data prior to having variable speed limits. You'll see that there's one vehicle traveling 32 miles an hour, while another one is driving almost 84 miles an hour based on that histogram. That obviously creates a lot of vehicle conflicts. So when we put a variable speed limit in effect, we see that speed distribution tighten up. And as the storm clears, we see it spread out, and we see the storm kind of move towards a normal histogram again. Next slide, please. One thing that we saw that was a problem for us is that we struggled to get the speeds raised properly. I think Utah said the same type of thing. So we've come up with some additional ideas to do what we consider a semi-automation process to be able to raise those speed limits more rapidly. Next slide, please. What we did is we came up with a way to integrate and automate. And again, we're talking about semi-automation. And the reason I say that is that we have our algorithm. You saw what it looks like. It's basically, like I said, based on stopping site distance. We have our road weather information systems. We also involve our AVL. So if there is a vehicle, whether it's a patrol vehicle, and I should point out that patrol is part of WYDOT here in the state of Wyoming. So we allow for patrol officers and maintenance people to tell us you're wrong on this variable speed limit. So they can, if they're in the zone, we'll ask them. We had to come up with a process to be able to take the misfiring AVL information and the misfiring RWIS information, as well as any misfiring speed sensing data, to be able to exclude it. So we did that as well. And then we pushed that information with a recommendation directly to the Transportation Management Center. We have a process that we call the data broker. That information pulls from a lot of different sources and then pushes directly to a product from the state of Minnesota called IRIS. That's our advanced traffic management system, which then turns that information directly to the roadside. So the TMC does see all the information. They have an opportunity to review that with a person on the ground, or they can just let it push automatically. If they don't act in a certain amount of time, the information is pushed directly to the roadside. Next slide, please. So this is what it looks like. This is the type of information that the TMC gets in what we call a track console. It's a transportation reports and action console that we wrote that tells them what the posted speed is, what the pace speed is, what the recommended speed is, and then they can, if they don't respond to this in a rapid amount of time, it pushes directly to the roadside systems. But they do have an opportunity to say there is a person in the zone and we're going to be checking with that person before we actually push it to the roadside. Next slide, please. So we have 9 variable speed limit zones across the state. The first one kind of in that kind of that army green color, that was placed back in February of 2009, directly after we got the legislation passed. Since then, we've been pushing this across a number of different hotspots. Interstate 80 in Wyoming is covered by about 45% of variable speed limits. So next slide, please. So I don't want anybody to go away thinking that we don't continue to have some multi-vehicle crashes, because we do. But the severity and the frequency has greatly reduced with variable speed limits. I think I'm right in saying that I know of 1 fatality that's happened due to a multi-vehicle crash in a variable speed limit zone in the last 15 years that we've been operating these. I could be wrong about that, but that's to the best of my knowledge. Next slide, please. These 2 crashes that I'm showing, can you go back one just for a second? I apologize. Can you go back one slide? This crash that happened, just hold that in your memory for a second. This happened in a variable speed limit zone where we had the speeds reduced to 45 miles an hour. Next slide, please. This crash happened about 1 mile away from a variable speed limit zone where we were not able to control speeds. You can tell the severity was much greater. We had no fatalities in the previous slide. This one we had a few fatalities. Unfortunately, people were trapped in their vehicles when the fire started and were unable to get out. So it was not a good situation whatsoever. I will tell you that the FHWA has also done some additional research. I think it's about 3 years ago they did a report. Just reading from one line of it, they said their analysis statistically found a significant reduction in large crashes, from 28.8% reduction in property damage only crashes to 65.2% reduction in rear end crashes. And then they also pointed out that the benefit cost ratio for these was about 9.05 for variable speed limits in the state of Wyoming. So that's what I have for you.
All right. Thank you, Vince, for that. Now we're moving on to our Q&A portion of the webinar. I'll just ask attendees to enter the questions via the Q&A chat bar on the bottom of your screen. Also, speakers, when you're answering questions, turn on your camera and say your name when you're responding. We have quite a few questions on the chat. Let's see, some of those have already been answered, but we'll start with one. One of the first ones here, and it was towards Les. Les, do you have marketing strategies aimed at the road users to explain VSLs prior to implementation?
There are some agencies who have done specific marketing strategies for that. I can't put my finger on any of them. I don't know if any of the other speakers have, especially Utah or, well, any of them may have. I'm thinking Utah and Wyoming because of the length of time that they've been doing this.
Okay. Does anybody else want to speak to how they marketed VSLs to road users before implementing them, or?
We didn't. We just put them up. They saw the signs for a long time, and so they were digitally on, but not changing for quite a long time. So there was already an acclimation to that. So.
No, I think back in 2014 there was a press release, but I'm not sure if we did more than that.
Yeah, it was pretty brief, but we've had more coverage ongoing. Like when we get a lot of great media coverage during snowstorms, so that's usually part of some of the things we talk about. So the awareness is there. When we put them up, a lot of the comments we got was, "Well, it's about time you did something like that," because people are obviously anxious and concerned of that. So
In Wyoming, we did press releases, but we also did some video releases as well. So our public affairs team did what they called a whiteout report, pushed those out to media outlets so that they could put it on broadcast media.
Yeah, in Pennsylvania, we do press releases leading into every winter about these. So just to remind everybody, and then there's a project website for the permanent corridor down in I-76 that's referred to frequently.
All right, thank you. Next question. And this one happened during Les's presentation, but I can open it up to anyone. Are there some universal thresholds for when VSL is a desirable option?
I haven't seen anything that I would call a universal threshold for that. I think generally it's if crash experience and speed differential are higher than you would hope for, and you're looking to solve that problem. VSL is a good solution to that, but I don't know of any specific thresholds or anything that are used.
Okay. Next question is, it happened during the UDOT presentation. It says, are you controlling VSL signs in your ATMS?
no, we have a separate module that was custom built. It does work with the ATMS directly. The same people that understand how that works already, they made the customized module, but it can also run because the algorithm had to be built inside that. So it just basically feeds out to the layer in the TMS about what to post on the sign. So it's like a 2-digit VMS or DMS, depending on what you like to call it. So that's about as far as that connection works.
And then follow-up question to you, Rod. Does the implementation of ITS monitoring vary between eastbound and westbound?
Oh no, they're pretty much hand in hand for our situation, because the biggest significant change is that there's a lot of we didn't go into it deeply. There's a lot of vertical and horizontal curves in that corridor, and whether you're going uphill or downhill, can make a big difference, or where the storms are setting up. Cody, I don't know if you have some more storm specific analogies with that. I mean, they'll run independently, so they're not tied together, but it depends on the conditions of what's happening with traffic in that direction. So, and also with where our snow maintenance teams are in the process of dealing with it. Maybe they're moving in the westbound direction, but eastbound is still in poor condition. So the speed limits will adjust to the changes, and so it's independently bidirectional.
Anaf, you have a comment?
No,
I'm sorry.
Thomas, did you ask me any question?
It says here on the chat box that you wanted to answer that question.
No, so I'm just moving the question that has been answered to the answered part.
Oh, okay.
I have no
Okay.
comments, thank you.
I'll point out that in Wyoming, the variable speed limits are completely independent directionally. We can't have conditions in one direction of travel that are different than the other. So we do treat those independently.
And I alluded to this a couple of times, but we are in the process of bringing ours into our ATMS system to use our integrated corridor management module.
All right, and this is a general question too, and it's a question about the relationship between when a VSL is active and Google Maps. So when a VSL is functional, does it show on Google Maps, or have you been coordinated with Google or anything like that? Let's start with you, Ryan. You're nodding your head.
Well, this came in during, looks like UDOT, but I'll answer it just from my perspective. We spoke with Waze about this, and they said they're open to receiving VSL feeds if we can put that in what we have with them. I don't know about Google, but Google owns Waze, so maybe it could go through the back channels that way. But I will say, we were a little surprised driving in a Ford vehicle the other day, how they were getting all of our temporary work zone speed restrictions in the Ford vehicle. So someone's getting this temporary, but I'm not aware of VSLs yet. So maybe some of the other states could answer.
We're not directly tied in yet. We want to try to do better at that. When we have our travel information website does have an API that does have the variable speed limit information coming through on it. So there could be a way to track it that way if a provider were to use the API. But we do want to, those are opportunities for us to expand how we do that.
Okay, thank you. Looking for the next question. Okay, here's the next question. What, and it happened during the UDOT presentation, but I'll open up to the panel. What is the frequency you typically use to update speed limits?
For us specifically, we do one, well, ours changes as frequently as maybe 3 to 5 minutes. And what we do is we take 1 minute sampling intervals at each of the detector stations. And we have to have like 3 concurrently changing or declining or rising speed changes that would warrant jumping to that next 5 or whatever the number it's averaging to. But we could do it that frequently. And we do it. That's when it's an automation, it'll do that throughout the corridor.
You mentioned the 5-minute interval of the RWIS, but the system will, I don't know if it's every minute, but we'll just take the last 2 observations of the RWIS, whatever interval we're at in the system. So
that's the part for the weather part, right, Cody? So the weather part could be a change every 10 minutes would be warranted from the weather alone, but the traffic side could be up to 3 to 5 minutes. So
We do something similar in Wyoming.
And ours is manual for our temporary right now based off of conditions, but we're piloting automation and it has the ability to do every sign pull, but we're leaning towards 5-minute RWIS station pulls.
Okay, thank you. Next question. Can different advisory speed limits be considered for commercial and non-commercial vehicles in your state, or can they use different traffic lanes during adverse weather conditions?
Can I take that one?
Yeah.
That's really contrary to our processes. We're really, in the whiteout conditions, we really don't want to have a speed variance between the different classes of vehicles. So we apply a speed and it applies to commercial and non-commercial vehicles. Much like I said, we're really trying to harmonize speed and not create a speed differential.
I see. Yep. Also in the state of Texas, that's against the law. We cannot have a speed for different type of vehicles. So I don't know how it is in your state. Chris, you have?
we could do that. In fact, we don't for the variable speed limit, but we have the section on I-15 did have a truck speed through that corridor that was different than the regular speed, and they had to combine those as one to, in our policy process to make sure. So at that point, we stopped differentiating to apply the variable speed limit system to it. What we found though is that when we left this variable speed limit in automation outside of winter hours, we noticed that traffic wasn't going as fast as it would have warranted the higher speeds anyway. So that was a good indication that the speed differentials were closer together, a smaller differential. So, but that brought some conversation about how's that corridor working.
Thank you. Thank you. Very insightful. In this next question, it's a long one. It says that the NWS WFO in Iowa did a study that showed as many crashes occurred on the roads after the weather event has passed as did during the event. So speakers have talked about wanting to get the speeds back to normal. after the event. But it was okay for it to take a while. Any thoughts on that from any of the speakers? Or do you guys still have a VSL after the weather event is done, Vince?
We tend to make sure that the speeds and the weather conditions are clear for about 30 minutes after a storm event. So we do kind of try to even that out a bit.
For us, since they run an automation, they kind of come out of the event fairly quickly. But anecdotally, we have not seen that be a problem with any crashes following the event. So
with the RWIS keeping, if those variables come back, it'll end, but hopefully we're holding on it long enough at the tail end of an event, defining what we mean by after an event, but hopefully it holds on long enough to limit crashes. So
Here's one benefit to being manual. We generally keep ours in for a longer period of time due to those lessons learned, where when they've been blanked too quickly, it causes more concerns, or increased, I should say.
I think for us, since our speeds are strongly reflecting on how the drivers are interpreting the conditions as they're changing, and in Utah at least, the conditions can, once our snowstorms can really roll in and roll out fast, whereas in other places there could be long lingering effects that are drawn out for hours, and we just don't quite have the same characteristics in our storms. It's not typically.
I think you certainly can write your thresholds to be on the way out. I really liked what Utah had there, as far as all the conditions need to be met. Those thresholds need to be met. If you are sensitive to writing your thresholds that way, it would address that, in my opinion. So that was one of the notes I took.
Yeah, I think we have time for 2 more questions, so I'll ask these last 2.
Tomas, can I just mention something? The question was moved, but someone did talk about the Aurora pooled fund study. I don't know if they got it answered. That is very relevant. So from my office's perspective, we're partnering with our weather office and that Aurora pooled fund study a lot. And they're talking about this additional data set that's going to bring in connected vehicle information, traction control. And we want to use that to increase the algorithm's accuracy as individual probe points out there on the road during inclement weather, because we just see that as the future in Pennsylvania. So whomever asked that, good forward thinking. We are exploring that in Pennsylvania.
Hey, we're on board with you, Ryan, too. We want to do that as well. Our connected vehicle program, we're trying to figure out how to ingest that kind of data from that to help with that algorithm. We're just not quite there yet, though.
All right, thank you for that, Ryan. I was kind of wondering where that question went to, but good thing you remembered it. So 2 last questions. How is enforcement handled? Do people get ticketed for going over the VSL during this adverse weather events?
I'll say for Utah, when we started this, we had the Highway Patrol in our meetings with us. In fact, the original request years prior to our starting, it came from one of our Highway Patrol lieutenants, and they weren't doing it for the perspective of having ticket writing being a high priority. They just wanted the corridor to operate more effectively and efficiently and safely. So they're not, on a rare occasion, they might cite somebody. I've only had a couple of requests for information related to somebody being cited, but we have not. And that's why we put the information out on a website, is that, you can find whatever the sign was at any given time. But that's not been anecdotally something we're seeing happen during those events. Most people are just trying to safely traverse the corridor, and the Highway Patrol is mostly trying to enforce chain up restrictions or for larger vehicles that are taking place, and they're not going to mess around with any kind of speed enforcement during that.
I'll echo that. And in Wyoming, I don't think having a blowing snow event is the right time to actually do enforcement. I think enforcement is done best when the conditions are mild. And I do think that patrol's presence is really important, though. We have crossovers on our interstates, for example. Having those guys in the crossovers with lights flashing so people know they're there, I think is really important.
Let me come back to that question now that I read it again. So ours is a regulatory speed limit. So if you are going over it, you can be cited for going over the posted speed at that time. But I think what happens is that when a high patrol is probably driving the corridor and somebody's getting passed, or they're getting passed by somebody, it's probably when that happens.
We have seen tickets. I know you got to wrap up here, Tomas.
Yeah.
I'm sorry. We have seen tickets for too fast for conditions. We have that in Pennsylvania. I don't know if anybody else has that, but they're not going to generally write you for speeding.
Okay, yeah, so we need to wrap up. If we go to the next slide. Thank you. I want to say thanks to all the presenters. If we were in an auditorium, I would ask for a standing ovation because you guys deserve it. You did great. I really appreciate all the information you guys shared. Slide after that, please. Again, here's a list of recently completed TMC PFS work products. You can go to the website here below if you want more information on the completed projects. Next slide. Upcoming webinars, we have one in October, which is actively managing operating part-time shoulder use. You can go to the website to find more information, and if you're interested in being a speaker for an upcoming webinar, please contact Job Auenbenger at john.auenbenger@dot.gov. Next slide. And continue to download and share resources from the TMS portal, as well as some new resources at the website here below. Next slide. Here's the closing poll that will pop out on your screen. And now, if the time is yours to close it out.
Thank you, Thomas. Thank you all to all the panel. This is the last request for everyone. You will see a couple of closing poll questions on your screen. Please go ahead and answer those. I'll give you a minute or so. We already received some answers. I know we're running over time, so if you could just answer those questions, that'd be great. So the first question is, are there any types of information, resources, or research conducted you would like to see that are not currently in the TMS portal? If yes, please specify. And the second question is, do you have additional TMS emerging topics you would like to see covered in an upcoming webinar? So I'll give it a few more seconds. Just please go ahead and answer the questions. In the meantime, I'd like to thank all the panelists for great presentations. Thank you, Thomas, for sharing the overview and also conducting the Q&A session.